Hello, YouTube and Steam. Wanted to show another cutaway here. This is the axe bow ship. There's the bow. Generally, the axe bow would not extend this far back. It would be a little bit smoother. Because of the game, I've had to add the upper section here for the fire piping and a little bit more airspace for when the ship nose dives into the water. And then this is a front ballast tank. This is the central fuel tank. Just above the central fuel tank is the central ballast tank, which will that'll lower it in the water. There's the port, it's just the exact mirror of this. Here's the stern tank, and then the engine room with its air pockets. The ship is self-righting for the most part. There is situations where if you leave the door open, it will not, but for the most part, it will self-right. The intent of this video today is to show the control sequences of how everything works inside of the ship. If you look, I've got a lot going on, like most ships in this game. Uh, uh, Most of what's happening up here is not overly interesting. There's a PID, which everybody knows how to use, and just general corrections up here for the helm controls and GPS. So not really focusing on this side so much because it's very typical. The main thing to show off is I am using a GPS or a gyroscope from a helicopter as my stabilization system. It's set to 0, and then that's what this does. I did find that if you got to send it a number. Leaving a blank doesn't tend to work as well. So you do have to end up sending it a signal. I'm going to start down here with our ballast control. That's what this little guy is right there. And the ballast control, what it controls is these pumps here. There's a couple of pumps. It's only 2 pumps in the front, and then it has 4 pumps. I'm sorry, 2 for filling, 2 for draining, and essentially it just uses the piping through the center of the ship to drain or fill as required. So if you look, that's my piping for it. We'll just focus in here. I've color coded most of the pipes in the ship. In this case, brown is for the drain, and tan is for the fill, or this reddish tan color. And then the red here is for straight red is the ballast, or is this control system for the not ballast tank, but the bilge system. So the bilge system is controlled by that. Right now, you have the ballast control, which will drain tanks, and the bilge system, which if you hit something or scrape the bottom, it'll start to take over. It's 2 pumps as well. That can take quite a bit of abuse. Moving into the chip control, though. Maybe. I guess it'll be a little fickle today. So in here, you do have a zeroing out reading. Right now, the stern, where I put my altimeters, this is all altimeter controlled. I found that everything else does not work well, but the altimeters work really well for the idea of stability. And essentially what the altimeter does is gives me the reading. The thing to remember is my stern is 1 meter higher, almost 1.75 meters higher than my bow. It's important to zero those out. So left to right, it doesn't have to be 0 across the board. There's a central reading, which every meter has its own. So like there's a central reading, and then port, stern, bow, and stern. The idea here is that your adjustment here is to make these all read 0 to each other. So the stern is 1.75 meters higher than the bow. So you can either adjust the bow or the stern, doesn't really matter. So we'll go in here and I'll show you the controls. So here's all the logic, but the logic's actually relatively basic, which is you have your meter, and then I can show you. Here's the proper that's the symbol of it. But essentially in here, what you've got is the property reading is that's the adjustment. So what it does, it takes the port meter, which is negative, makes it into a positive. The 2 numbers are added together, and then the starboard's the same thing. And then what it does is here's your roll adjustment. It adds it only to the port. So the port adjustment, that's why it's a negative number if you want it to go down, a positive if you want it to go up. Because the way that this works is it adds it together. And so that's how it adds it together, and then it subtracts the stern from the port. Sorry, the starboard from the port. And then when it's more than 0.5 off from each other, negative or positive, it then makes the adjustment. And all it does, If it's greater than or less than, that setting, what it does is if it's greater than, it will come through here. Um, these are the controls for the, this is the status light, this one right here, this one right here. This OR is for the drain all. So if you look, the drain all goes to the port and starboard drain using OR signal. So it comes through here as an AND, which means that the system's enabled, and there's that. Comes through, goes through the OR gates. These are spare OR gates that will be used in the future. And then here's the drains, here's the port drain and starboard fill. So that means that if it's deeper in the water than the other side, so port's deeper in the water than the starboard, it will drain the port and fill the starboard tank. So it's double reacting because filling the tanks is pretty slow. That's why you have to drain one and fill one so that you're not actually changing how far in the water it sits. You're just changing left to right. So that's the way. That's really just that repeated about as many tanks as we have, which in this case it's repeated 4 times because of the four channels of control. The drain all drains all the tanks, of course, which includes the bow and stern tanks, which is what you see. That's what this goes through, and when it's enabled, it drains all the tanks. So down here is our central elevation system. It's almost the same. The main thing is there's the adjustment of how deep it sits in the water, which I use 3. That allows this to be the actual elevation change that you're looking for. And then if you look, same exact control, except for I use 0.1 instead for the depth because of the variance in the water. And there's our greater than, less than, our and signals, and then it goes through the ballast tank fill and drain, and then our system active control. So pretty basic actually, but it looks pretty impressive on the actual board there. Coming back here, the next controller that's really impressive and then repeated is in our generators system. The way that the generator system works is the system is enabled by an enable charge point, disabled charge point, and then if you have a multi-generator control, this is where it will start disabling overdrive. Overdrive is that economizing mode, or economy mode, and I'll change the names to match. So if we come back here, I can show you the logic back here, which essentially this chip is a one-stop shop for generator control. Charge goes in, you have an enable that goes in, and essentially everything else it'll run on its own. If you just have one generator, you want to control it, that's all you need. Main thing to remember is you have there is a clutch control with an indicator. The idea of the clutch control is well, I mean, of course, everybody knows what that does. It just helps disengage the engine from the drives train to get it started. It's not necessary. It's only necessary when you have multiple generators hooked up. What I've done is I use buttons that I can come out and see. So all the buttons are replicated through, and then it goes to the actual connectors, and then there's throttle control. If you look at my gearing configuration, there's 2 configurations for gearing. The first gear set, which is this train right here, and gears are of course always given in trains. This gear is 3-to-1, 3-to-1, and then 2/3. These are up gears, so it's actually 3-to-1, not 1-to-3 like you see, because it's actually back feeding. So if you look, we actually have a back feed because the arrows are pointing the opposite direction, and one gear train on the left and on the right is just for this generator. So if you disable this generator, the left one will run independently of the right one. And what this does is it spins it up, and then it goes into this. This is the economizer gearing, and what that will do is this is the first overdrive for each independent gear, and then when both are running, then you can go into the second economizer, which will cycle this gear on, comes here to this, which makes sure that both generators are running, this is an and then this is a signal delay to the second gear ratio. If you look, we have another 2/3 or 3-to-2, and then a 6-to-5, and then that gets us around at 75 charge, around 2 RPS out of each generator, which will be connected. The chip for that is right here. What we got, again, lots of stuff to look at. Essentially what we have is everything's related to charge level on this side. You have the 85 and then 90, which is the 2 property numbers that you configure. And essentially that's the enable disable. And then we use a JK flip-flop in order to go through, and that's what makes this number change from the two settings of 85 or 90. Then we have our safeties. So essentially, once it's enabled, here's our safety chain, and it compares the generator temp. My target's less than 100. And then there's the enable. So when it's enabled and the charge is below the set point, it'll then go to this one. If it's less than the temperature, then it'll go, and then that'll pass all the gates, and then it'll give you a green status light. When that status light is active, essentially what's already been calculated in the game is it's already come through this chain. This chain is essentially what engages the starter. So all of this is just for the starter. And what it's comparing is if the generator is greater than 5 or less than 0.25. 0.25 basically means that the generator's off. It'll then compare that to the, and that's based on against RPS. So if it's above 5, we know that it's running, and then if it's above 0.25, that's after it's running. So what it means is the generator started up, it's been given a proven signal that it's gone above 5 RPS. It then switches it to not enabling the starter again until the generator slows down to 0.25. And then that's what switches right here between 0 and 1.5, and that's essentially the 1.5 is the starter enable, and then the 0 doesn't allow it to run the starter at all. That's what this does. Comes here when the RPS is less than that setting, and it'll then turn on the starter. The starter needs to have an enable signal and the starter and the RPS low, which turns that on. Right now, this is a bypass. I'll show you in the other generator what this system does, but right now it's just as 100% throttle. You can either control the throttle or you can control the gear train, and I'll show you that in the other generator. But this one's just 100% throttle. Comes through. This is the cycle off. So if the signal turns off or it's disabled or safety's tripped, it'll then send the throttle to 0, and then that's the throttle. So it just leaves the system right there. And then down here, that's the starter. Of course, that's going to be with all it is RPS based and enable based. Then what we've got is this is the start of the gear control down here. It compares that the RPS is greater than 1, which essentially means that it was started, or that the starter's run and got it engaged. It waits 3 seconds, and then after it waits 3 seconds, it sends an on signal. And what this does is when the starter's enabled, it locks out the gear train right here. That's what this OR does. This is a lockout for the gear train, and then this will lock out the gear train for 3 seconds after the starter's proven, which is that OR. Then it goes to a NOT, and because the signal needs to be reversed, and then that's what switches this box here from 0 to 1, which is the clutch control. So right now, when that's disabled, the clutch will be at 0. And then if that doesn't enable, or i.e. we don't need the starter, the clutch sits at 7%. 7% in this case is only on the one motor. That'll spin the motor where it doesn't actually have to start the starter when the other engine's running. So it'll start each other up from each other. And then it'll go to this box and the clutch control. It also comes down here to this signal here. So when the signal goes off, essentially when this thing is when this signal's off, this signal goes to on. On means that the consistent number goes to 100% throttle, and then or 100% clutch. I'm sorry, and then down here it goes to a hold, and then what it does, it enables the it turns off the gear lockout. I did use a gear lockout instead of an enable. You could go either way. I just like the gear system has to be enabled because it's 2 drive, and if you have 1 drive that is not enabled, it'll be spinning at crazy amounts of RPS because it'll just be direct driven to the end, and that's just not a good idea. And then down here, you can see I've got, this is the overdrive. So that's gear drive 1. Here's the overdrive control, which is based on a property slider. It's got a setting of 4 RPS, and in this case, it's got a setting of 1.5, which is the absolute minimum. The other engine has 1.8, and the idea here is that it cascades the econ mode off for everybody as the demand goes up or down, and so it prevents stalling the engine essentially. It comes through here, goes through the flip-flop, which is just going between the 2 settings. That's what this is right here. It's just going between 4 and 1.8. As long as the RPS is greater or in this, greater than each one of those, it'll enable the overdrive, and that the overdrive is the econ mode. So that's the generator control, 100% automated, easy, no problem. The other one we have is what's called the pony generator. Little different control sequence here because the pony generator is made to run, and its idea of life is actually to control based on a setting. So here's the charge level, and then a setting. And what it's going to do is it's going to control through a PID loop. This is the throttle control that isn't in the other one. The upper section is the same between both systems, but essentially what I've got here is this is where the setting of 90 is, 90% battery. And what it'll do is at 90% battery, it will, and that's default. If you do your own target, it'll come through. And that's all this is doing, switching between the two targets. If you give its own target, the way it works is it adds that target, and it adds based on this number right here. So 0.5, 0.05 above and below it. And then that'll enable or disable the pony generator, just like the other ones. It's just like a set point. But not to worry, don't worry about that. The main thing is down here in the PID control. And what it does is it's enabled when the charge is within 2%, which is what this is, of the actual set point. And then it'll control the throttle between 0.14 and 2. It's really 1 and 0.4. 1.4, I mean, and 1. Essentially, that sends it through to the actual throttle control. The lower half's the same as the other system, and then this is the same as that other overdrive. The only difference here is it's a higher number. That's just because of the engine type. Big diesels tend to be more resistant to shutting down, so I can use a lower number for those. The aircraft engine tends to be a little bit more fickle, and so it's a little bit slower. So this uses the PID loop to control the throttle, and that kind of tops you off. So that's how that works. And so that's basically it for those controls there. The whole idea here is to lower fuel consumption as best as possible, and keep fuel balanced and keep the thing functional. So that's it. That's the main kind of pieces of the ship to kind of look at. I guess we can do a little cycle through as you go up through the decks. You can see the lower deck. It's a double hull, bottom hull, even though you have a fuel tank here. But essentially, there's tanks on the bottom, give you a little resistance. So this is a dry compartment, and then as you move up through the ship, see that's our deck there. And what I've done to lower the center of gravity is essentially all the motors. You can see up here, the two middle motors are down low, almost in the lowest part of the ship it can be in. And essentially all the heavy stuff is below the water line. And so right now the water line sits about here. And if you look, what's below the water line is the generators, all the drive motors, and all the fuel that's the heaviest is underneath there. Fuel's buoyant, but it's down there. But you see, my generator on the forward section of these two generators are all below the water line. So ship's very, very stable. And then if you look, the back deck is just almost at the water line, and then it's just all airspace. This section here is where there's an opportunity to do some, I'm going to do some interior work there, and then there's some opportunities here as well. So you'll see there'll be some more changes coming. This is my primary ship that I use. So if you look, there'll be some more interior work coming through some of these empty spaces as time goes on, as I kind of keeping up with the changes and the changelog and stuff. So that's the ship. I really appreciate you watching the video, and hopefully you're not too bored. But I try to engineer my ships, lots of math, lots of doodles. So I mainly go for the functionality and the design, and less about the painting and stuff. But I think this is a pretty impressive looking ship. Just looks powerful from the ground up. So please download it and enjoy. And if you have any questions, leave any comments, or if you want anything added to it or removed, something mission specific, just let me know.